Finish him. Kill the guy now. You have the gun. Hit him. What's wrong with you?
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there's football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses like especially made for you.
I have you last semester.
We £5 on you. Very stupid though. Yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.
Good afternoon. You are welcome to another section of this class, CHE 214, Nuclear Chemistry. We met last week, and under this course, we discussed the kinetic calculations of a half-life. We were able to solve some questions on this particular topic last week. So this topic, we still continue with it this week by continuing to look at some problems and solution under this particular topic. So the fourth question, we treated about 3 questions last week. So we move to the fourth question today under this same topic. So the fourth question, the half-life the half-life of a radon is approximately 60 days. A tube containing 2 grams of radon was stored in a hospital for 12 days. How much radon remained in the tube? How much radon remained in the tube? The original mass of the radium at the initial stage is given as 2 grams. And at the end, after some times, when radium has undergone radioactivity, definitely some mass of it will have decayed. Now, after these particular days, 12 days, when it was kept in the hospital, what is the mass that is left at the end of the 12 days? Now, to go by this, our T half is given as a 60 days. And the original mass, which is N0, is given as 2 grams. And is kept in 12 days. So our T is going to be 12. And the number remain at time T is unknown. That is what we want to calculate. So with this, Our lambda is giving us 2.303 all over t, logarithm of n0 all over nt. But with this now, we want to calculate nt, that is the amount remain after a particular period of time. And lambda is not given here. So the first thing is to get a formula to calculate our lambda. Calculate lambda. Our lambda is having a relationship of 0.693 all over t. So, all over t half. So, our lambda is equal to 0.693. All over t half is given as 60. So, our lambda will be giving us, so if this is divided, if we divide this, we have 0.1155 days if this is divided. Now, since we know our lambda here, then we go back to the formula. And the formula says lambda is equal to 2.303 all over t logarithm of n0 all over nt. So we have our lambda, which is 0.1155, which is equal to 2.303 all over t. What is our time? Our time is given as 12 days. So we substitute it there, 12. Then logarithm of n0. What is the original mass? The original mass is 2 grams. That is 2 all over nt. So we have 0.1155, which is equal to, we divide this by this. So if we divide 2.303 by 12, it's giving us 0.1919. Then log of 2 over nt. We divide this by 12. So it's giving us this. So the next thing to be done here is to divide both sides by 0.1919. That means we are having logarithm of 2 all over nt is equal to 0.1155 all over 0.1919. Dividing both sides by 0.1919. So we have to divide 0.1155 by 0.1919 again. Logarithm of 2 all over nt is equal to, if we divide this by this, what's it giving us there? If we divide that, we'll be having 0.6019. 0.6019. So at this junction, we are going to take the logarithm of both sides. Take the logarithm of both sides, will give you 2 all over nt is equal to arc log 0.6019. So we press the second function log of 0.6019. So if we have 2 all over nt now will be equal to, if we divide that there, we have 3.9985. That is the second function log of 0.6019. So we cross multiply now. We cross multiply. So this will multiply this. That's 3.9985 nt is equal to 2. So we divide both sides by 3.9985 to get our nt. Nt now is equal to 2 divided by 3.9985. So my nt now will be, if that is divided, that will give us 0.50 gram. So that is the amount remain after 12 days. After 12 days this is 6 grams. After 12 days that it has been kept in the laboratory. So the amount left out of the 2 grams that was kept is 0.50 gram. Yeah, let's see question number 5. Question 5. The activity of a radioactive isotope reduces by 25% after 100 minutes. Calculate the decay constant and the half-life period. Yeah, this is another question here. The activity of a radioactive isotope reduces by 25% after 100 minutes. Calculate the decay constant and the half-life period. When we talk about the decay constant, we are talking about the lambda there. Decay constant is the same thing as the lambda there. So to calculate our decay constant here, let's first look at the parameters given in the question. We are given our T to be equal to 100 minutes. We are given our, they said 25% of it decayed. That means the original mass is going to be 100%. So that means N0 is the same thing as N0 is equal to A and is equal to 100%. While NT is equal to A minus X, which is equal to 100 minus 25, which is equal to 85%. So that's going to be 85x A minus X. The number reduces by 25%. So if it's reducing by 25%, it means our A minus X is NT, which is equal to 25%. Since they said it reduced by 25%. Now we have to calculate the decay constant. The decay constant is lambda, and which is a 0.693. 0.693 divided by T half. And according to this question, we are not given the T half. So automatically there, this formula cannot be made use of. It is a relationship between the lambda and the T half. Adding the T half is given now, this formula can be made use of. There is another formula which says lambda is equal to 2.303 all over T logarithm of N0 all over NT. And with this, we know our time from the question. We know N0, which is the original mass of the isotope. And we know our NT, which is the mass remain after time T. So this is equal to 2.303 all over t. What is our t? Our t is given as a 100 minutes. 100. Then logarithm of n naught all over nt. Our n naught is 100 all over nt is 25. So this will be 2.303 all over 100 logarithm of 100 divided by 25 is equal to 4. So at this junction, you can use different methods here. You can check for the logarithm of 4. Multiply it by 2.303 and divide the product by 100. It will give you your answer. Or you first divide 2.303 by 100 and multiply the result by the logarithm of 4. It will as well give you your answer. So if I divide this by this, it's giving me 0. My lambda is equal to 0.0203, which is equal to, then logarithm of 4. So my lambda is equal to 0.0203. Logarithm of 4 is 0.6021. So what I've just done here is I divide 2.303 by 100. I divided 2.303 by 100, multiply by the logarithm of 4. So this is the division, and the value of logarithm of 4 is 0.6021. So if this is multiplied out, you have your lambda to be equal to 0.01387 minutes. So that will be the value of our lambda. That is the decay constant of the radioactive. That is the decay constant. Now, another question there says we should calculate the half-life of the period. So that's question 2 there. Half-life, which is T half. So we have our lambda to be equal to 0.693 all over T half. That means our T half is equal to 0.693 all over lambda. And we have calculated lambda to be this. So that means my T half is equal to 0.693 all over lambda. The lambda we have calculated here. That's 0.01387. 0.01387. So T half, when this is divided, is giving us when we divide that, we have 49.96 minutes. That means T half can be approximated to be 50 minutes. That's to the nearest O number. So that is the value of our decay constant there and the half-life of the particular isotope. So that's that. Let's quickly look at another question, which is question number 6. Calculate the disintegration constant of cobalt 60 if its half-life to produce nickel is 60. To produce nickel 60 is 5.8 years. Yeah, this is cobalt subjected to radioactivity and nickel is produced. So they say calculate the disintegration constant of cobalt 60 if its half-life to produce nickel 60 is 5.8 years. This is very simple and straightforward. What are we looking for? We are looking for decay constant. That is lambda, is unknown. And from the question we are given T half, which is equal to 5.8 years. That's all. So that means, and we know the relationship between our lambda and T half. Our T half is equal to 0.693 all over lambda. That's all. T half is equal to 0.693 all over lambda. And we know lambda is equal to 0.693 all over T half. So my lambda is equal to 0.693 all over, what is T half? T half is 5.8. So my lambda is giving us, so if that is divided, that is 0.12 years. There. That's per year. Per year. So that is the lambda there. So we continue by looking at another question here. Seven. 3 grams of a radioactive element degraded to 0.8 gram in 60 hours. In what hour will it be reduced? Will it be reduced to 10% of its original atom? Yeah. 3 grams of a radioactive element degraded to 0.8 gram in 60 hours. In what hour will it be reduced to 10% of its original atom? Our lambda is equal to 2.303 all over T log of N naught all over NT. So here we are giving our N naught to be equal to 3 grams. NT is giving us 0.8 gram. and our T is given as 60 hours. And we are looking, they said in how many hours? That means we are looking for time T. So our time T in what hour will it be reduced? So we are looking for our time T. So time T is equal to 2.303 over lambda, then logarithm of n naught all over nt. So T is equal to but we don't know our lambda, 3 grams of this. We don't know our lambda. So let's first calculate our lambda there. Lambda is equal to 2.303 all over T log of n naught all over nt. So lambda is all over T. T is giving us 60 hours. So that's 60 log of my n naught is 3 grams and nt is 0.8. So that's 3 all over 0.8. So lambda is equal to 2.303 over 60 logarithm of, if this is divided by this, it's giving us 0.75 log 0.75. Lambda is equal to 2.303 multiplied by the logarithm of this. So we find the logarithm of this multiplied by this. So multiply by 0.5740. Everything over 60. So that means lambda is equal to, if we multiply this by this, it's giving us 1.321922 divided by 60. So my lambda is equal to 0.022032. That means lambda is equal to 2.20 times 10 raised to the power minus 2 per hour. So I've taken this to an exponential form. 1, 2. So that was 2.20 times 10 raised to the power minus 2. Now, we've gotten our lambda now. The question is this. It said we should calculate T. It said we should calculate T. To calculate T now, we still make use of lambda equals 2.303 all over T log of n naught all over nt. Where my n naught now is equal to 3 and lambda is equal to 2.20 times 10 raised to the power minus 2 and nt is equal to 3 minus 10% of 3. So that means nt is equal to 3 minus, what is 10% of 3? That is 10 over 100 times 3 over 1. So nt is equal to 3 minus 0.3. So nt is equal to 2.7 grams. So that is the value of T. So quickly, so knowing the value of T there now, lambda equals 2.303 all over T is given as a Okay, we are calculating T. So this is T all over lambda. Lambda is 2.20 times 10 raised to power minus 2 logarithm of N0 is 3 all over 2.7. So T is equal to 2.303 all over 2.20 times 10 raised to power minus 2 logarithm of, if we divide 3 by 2.7, it will give us 1.1111. So getting the logarithm of this, T is equal to 2.303 multiplied by, logarithm of this will be 0.0458 all over 2.20 times 10 raised to power minus 2. So my T now is equal to, if you multiply this by this, it's giving me 0.1054774 all over 2.20 times 10 raised to power minus 2. So T is equal to, after dividing that, will give us 4.79 hours. So that will give me the value of my T. So far so good. We've been able to treat about 7 different questions on this particular topic. So this is where we are going to stop today. By the special grace of God, we continue with another version of this same course by next week. Thanks very much. Play safe and stay safe.
Okay.
Finish him. Kill the guy now. Round the corner. Hit him.
What?
What is this? Good day, sir.
You are watching Jackie Pan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have last semester.
We eat by pounds on you. Very stupid. Oh, yeah, change that section to ACTV right now. And oh God, you go to what you first born. Stupid boy.